In this video, we will talk about the idea of singular value decomposition and its role in finding the pseudo-inverse of a matrix. So SVD stands for singular value decomposition. Okay. So SVD is actually a method to factorize a given matrix. Imagine that I have a matrix H. Then I can factorize this matrix into three different factors. I am writing it as U, sigma, and V transpose. U, sigma, and V transpose, where U, sigma, and V are three different matrices, and I will write the dimensions here. Suppose that H is of dimension m by n, U is of dimension m by m, and V is of dimension n by n. So if you want to make the multiplication agreeing with the dimensions, then the dimension of sigma should be m by n. Now if you have these matrices, that is U, sigma, and V, or V transpose, we can write the value of the pseudo inverse, that is H minus, equal to, we first write the V, then we write the sigma pseudo inverse, then U transpose. So you might be thinking that if you want to find the inverse of a matrix, we need to again find the pseudo inverse of another matrix. But finding the pseudo inverse of this sigma matrix is rather easy. Suppose that this sigma takes the form, suppose that I have value, let's say 1, 2, 0, 0, 4, 6. Suppose that these are the values of sigma. Then if you want to find the pseudo inverse of sigma, what you have to do is you have to invert all the non-zero elements in this matrix. So the value of this first one will be 1 by 1, that is 1. This will be 1 by 2, and you will be writing 0 as it is, 0, then 1 by 4, then 1 by 6. Then we have to take the transpose of this matrix. So it will be, first I will have 1, 0, then 1 by 2, 1 by 4, then 0, 1 by 6. Okay, so once you calculate all these values, whatever you get will be the pseudo inverse of the matrix H inverse. Matrix H, we designate that it as H inverse. So once you have the value of H inverse with you, or H pseudo inverse with you, then you can find the estimate for a given image, that is f hat equal to H pseudo inverse G. And we have seen the same equation in the previous video also. So we will be substituting the value that we got from this relation directly here, so we can find the estimate or the restored image using this relation. So we saw that we can use the singular value decomposition matrix factors to find the pseudo inverse of a given matrix. Then we can in turn use the same matrix to find the estimate of a degraded image in order to restore the image. Now let's see an example of Matlab on how it is finding the pseudo inverse of a matrix. So let me clear this. So suppose that I have a matrix, let's say H is equal to, I'm initializing a random matrix with maximum value of 10 of size 2 by 5. So this is my matrix H. And if you want to directly find the pseudo inverse, now there is an equation, there is a function in Matlab called PINV, and if you directly pass the value of the matrix, then that result will be the pseudo inverse of the matrix. And if you want to find the pseudo inverse by using the factors of singular value decomposition, then you can find the singular value decomposition matrix matrix from using this function. So I'm actually storing the factors in the matrices U, S and V, that is U, sigma and V equal to the singular value decomposition, that is SVD of H. So this will be giving me three different matrices with these values U, S and V. So when you look at the value of V, even though the equation was V transpose, this function is giving us the value of V. So we do not want to take the transpose. So if you want to find the P inverse, you can directly take that matrix V as it is. So the H inverse will be equal to V into, then if we want to find the value of P inverse of S, that is sigma. So you can see that this is the matrix. So if you find the P inverse of S, what you can see is we will be taking the reciprocal of this value, also this value, then we will write those values there, then we will keep all zero values as it is, then we take the transpose. So once you find the value, those values, you can see that the matrix will have this shape and the numbers will be like this. Now I am finding the H inverse using the values of U, S and V. So I am writing it as H underscore I is equal to, first I am using V, then multiply that with the P inverse of S, then multiply that with the transpose of U, that is U transpose. So this is the value of H inverse, and if you want to verify, you can use the function P inverse of H, and you can see that both functions or both calculations are giving us the same result. So I hope it is clear. Thank you.